Hi and welcome to my talk. My name is Eike Langbehn. I'm from Curvature Games and I will talk about the development of one of our games, which is Frozen Factory. The talk is entitled Frost Mortem, Bending Space Without Bumping into Each Other. And this means it's a post-mortem talk, so yeah, I will just recap the development of the game and what went good, what went bad, and what we have learned during the development. Let me first introduce our team. This is Curvature Games. It's a company that we founded beginning of last year, in January 2020. Dennis, Hannah, and me. And at the moment, we're a team of 8 people, and we are working exclusively on virtual reality games. We're based in Hamburg, and we're basically a spin-off of the University of Hamburg. And yeah, we use our company, our little startup is based on a technology that I developed during my PhD thesis at the University of Hamburg, and we'll also talk a little bit more about this technology during this talk. Okay, so Frozen Factory was the first game that we developed with this company. It's only one of several projects that we're working on or that we have worked on already. And since it was our first game that we worked on together, it was also a kind of learning project. Like we learned how we need to work together and what we need to do to be able to work to achieve a good result. And this is also what this made this project very challenging. So let me first just show you a short trailer about the game so you have an understanding what it is about.
Penguin workers, welcome to the Frozen Factory ice cream vending machine. You have 15 minutes to make this boiling ice cream.
Yeah, so as you've seen, it's a fun multiplayer game with penguins. And it's a game for location-based entertainment. That means you cannot play it at home, but only at certain locations like VR arcades, family entertainment centers, and so on. And we only need very few equipment for this. Basically 2 standalone headsets. Right now we support Quest and Pico, and a laptop that runs the server software and Wi-Fi for the local network that the laptop and the headsets are connected to. And you could play it with 2 players in a space of 3 by 5 meters, so both players will share the space. And that's it. And this is can then be played, basically everywhere in each location that owns this equipment. We had some really innovative interactions in this game, and this is what I will mainly talk about in this talk. And I want to start with presenting the design goals that we thought about in the beginning. So of course we wanted to make a unique and presence enhancing game. It should be just a good experience. But we also targeted to have it easy to learn and family friendly. As you have already seen in the trailer, this is what we mean by family friendly. It's not a violent game. It's a game that can be played by kids and by adults. Ideally, a grandfather would play this together with his grandson in a VR arcade. So this was the goal of all the art design and the puzzle design and so on. But more important during the design process was our easy to learn approach, because it's a game that only lasts up to 20 minutes, so it's experience between 10 and 20 minutes. And if you go to an arcade and want to play it there, you don't have so much time to learn it. If you only play it 10, 15, 20 minutes in total, you need to be able to learn it within seconds. So there was not much time to explain anything to users. And also the customers in arcades are, or yeah, you cannot expect that they have gaming or VR experience. So this became one of the most important things, that it needs to be easy to learn. And also because of this, we had the third point where we said we don't want to have any wires, any tracking stations, or any controllers in this. It should be really easy to set up. So I already showed the technical hardware setup. As we have standalone headsets and a laptop, and that's it. So we don't need any tracking stations that need to be calibrated. We don't have any wires on what this is good. And we also did not want to have controllers, because it's just an additional thing of hardware that you have and that you need to that the users need to wear. It's and that you need to explain in the beginning. You need to explain, okay, this is a controller, and button A is for this, and button B is for this, and they need to learn this, and this takes time. And we wanted to be able to bring the people directly into the experience without being without it being necessary to explain so many details and explain the controls. And so we decided to skip controllers, and these design goals led to some challenges during development. So mainly 3 challenges. The first one was, okay, if you don't have controllers, we need to be able to have another kind of interaction device, and so we chose hand tracking. So the users in the game can directly use their hands without using controllers. This was possible when we started the development. This hand tracking feature of the Oculus Quest was quite new, but it was there, and we thought, yeah, it's a great fit. Let's try it. The second challenge is that we also wanted to have a free roam game, so that the users are able to naturally walk inside their tracking space without using things like teleportation or virtual like joystick locomotion or something like this. And this wouldn't even be possible without a controller. So because we had no controllers, we also couldn't do something like teleportation. But of course, we also wanted to do this because it's easier to learn. If you can just freely explore your space, like in real world, you don't need to learn how you walk in VR. This also pays into this easy to learn approach. And the third challenge was that we wanted to enable co-located plays. So both players share the same tracking space. It's only 3 by 5 meters, and we have 2 players in there. And this also came with some challenges, especially during development, and also in combination with the redirected walking approach that we had. I will tell more about what redirected walking exactly is later on, but it's it's a locomotion technique that enables the user to freely and naturally walk in VR without being limited by the size of the tracking space. Okay, I now have a little larger video that explains the concept of the game in more detail. So let's watch this together.
Frozen Factory is a cooperative puzzle game for 2 co-located players who are both redirected simultaneously to simulate a much larger play area. Players are penguin workers in an ice cream factory. The player's ultimate goal is to produce an ice cream for a demanding customer.
Where's my ice cream?
Both players must complete a series of cooperative tasks against the clock, such as baking a cone or whipping cream. The game is built for standalone VR headsets. The players just need to mount the headset and they are ready to go. No wires, no tracking stations, and in some cases, no controllers are needed. The game can be played entirely with networked hand tracking. Players do not need to know how a game controller works, instead they just intuitively use their hands, just like real life. Interactions do not involve complicated gestures, it's just everyday actions, such as pushing, pulling, or touching. One of the most unique things about Frozen Factory is the locomotion technique. Instead of using joystick steering or teleportation, the game leverages redirected walking techniques, which guide the players on paths in the virtual world that differ from those in the real world. Both players share a 5 by 3 meter play space. Inside this space they can roam freely. At certain spots in the game, rotation gains are applied that turn the players around. This way they're facing the play space again. This is seamlessly and deeply integrated into the gameplay and interactions. While the player is concentrating on perhaps filling a cone with ice cream, the world is turned around them. This way the players can explore a virtual environment that is much larger than the play area. Frozen Factory is a fun multiplayer game for 2 co-located players. We leverage redirected walking techniques to create a unique, easy to learn, presence-enhancing user experience.
Okay, so you saw that there was a hand tracking, that they shared the same play space, and also this redirected walking was explained a little bit. And yeah, these are the main unique things about the game, but also the things that yeah, were the most challenging during development. Let's start to look a little bit deeper into a hand tracking interaction. And this was tricky because there was no standard when we started the development. It was just, yeah, you could do it. It was a quite new feature. It was still in beta state when we started. And we, yeah, played a little bit around with it, what you can do with it. And soon we realized that we don't want to use single finger tracking. Yeah, this was still not as good as we would wanted to have it. So and also it comes with a lot of problems regarding physics and collisions, and so so what we only used was we basically just tracked the hand, the position and orientation of the hand as one transform. So we only have one transform per hand in the game, and that's it. That makes it a lot easier, but also more robust and reliable during the experience. And of course, it was very like it was a good idea for us to do this because we also had these. We decided to have these penguin avatars in the game, and the players are penguins in the game, and of course penguins don't have fingers; they have flippers. So it worked quite good in our setting to not have finger tracking in there. And then the challenge was to find interactions that work when you only have one transform for your hand. And you can't really do a lot with it. We wanted in the beginning, we thought we could also implement that you can grab objects and that they stick to your flipper somehow, and then you can like remove it from your flippers again by, I don't know, shaking your hands or so. But it turned out that this wasn't really a good approach. It was too hard to understand how you would grab an object, how you would remove it again, and so on. So in the end, we just implemented the flippers with colliders, and you can just like basically collide with everything in the world. So you can push things by just like pushing them, as you can see on this screenshot. There's a puzzle where you need to collect the correct ingredients, and you do this by just pushing them on another conveyor belt. And all the interactions and puzzles in the game are basically just based on simple collisions. Here you need to steer these drones for the ice cream with a little joystick in front of you, and you can just collide with the joystick, like the flipper, let your flipper collide with the joystick to move it to the left or to the right. And another example, we also had some buttons or button-like interactions there. So we just had this button, you just needed to push or touch this button with your flipper, so only just a simple collision. This was also a good idea. So all interactions in the game basically are based on the same principle. You just need to collide with objects. So it was very easy to learn. After you've learned this one time, you could apply it to all interactions during the whole game. You don't need to learn a second kind of interactions. You don't need to learn buttons. You don't need to learn how to grab things. Just yeah, that you know you can collide with things is enough to play the whole game. And but it still enabled us to do some variations. So it was not every interaction, not every puzzle was the same, but we could create a range of different things, like these buttons, like these joysticks, the objects that you can push. So there was variation, even even that we only had basically one kind of interactions, it would still enable us to do a lot of things. Here again, we tried to implement that you can grab things and carry things. This doesn't work, and the players already learn this right in the beginning. So in the beginning of the game, we have a short tutorial room where you can try all interactions that are needed for the game. So pushing, touching, and that's basically it. And if you try to grab the statue, then it falls down, and it teaches you, hey, you cannot grab things in this game. It's just not possible. But it's fine. So the players were really able to learn this kind of hand interactions in a really short time. Okay, let's come to the second challenge that we had, which was locomotion. I already told you that we did not want to use virtual locomotion, so no joystick shifting, no teleportation. We even had a controller to do this, so because we just had hand tracking. So we wanted to implement real walking, but we didn't want to be limited by the available tracking space size. And this is why we used redirected walking. This is also the technology that I worked on already before in research. And in academic research, there's already a lot of work on this. The first work was presented 20 years ago. And you can see it here. And the basic idea of redirected walking is that you walk on different paths in the real world than you perceive in the virtual world. So in the virtual world, you perceive that you're walking on a straight path, but in the real world, you're guided on circles, on circular paths, or back and forth, like you can see here. The blue one is a virtual room, and the red one is a real room, the tracking space, and in the real room, you're just walking back and forth, basically. And there are different techniques to achieve this. You can have different redirection techniques that do different things, but they're all based on the same principle, that you decouple real and virtual motions. And it showed that, it has been shown that this increases a sense of presence, so you feel more immersed, more present in a virtual environment, better than with joystick movements or something, or teleportation. It also showed that it reduces VR sickness, or at least it does not increase the VR sickness. So for example, it is known that for joystick movement, where you have a fast virtual movement, but you're standing or sitting in place, a lot of people get motion sick, and this does not happen if you actually walk in the VR space. And it was also shown that it increases, or that real walking increases the spatial knowledge. So you get a better understanding of your surrounding. You can better remember what the room looked like you walked through. Just your spatial knowledge is better than, for example, for teleportation, because when using teleportation, you only have these certain steps where you see the environment from. but when you use real walking, you really walk through a room and get much more spatial knowledge there. So here's an example what you can do with redirected walking, and how you can also incorporate physical props into this. The user has the task to go in this room and grab this ball from a table and then walk back the corridor, and at the end of the corridor the second room, and there you should, well, the user should put the ball back on the table. But in the real world you're guided back to the same table. So you have, in the virtual world you have two different rooms with two different tables, but in the real world it's just one table and you're guided back to this by these redirected walking techniques. At Curvature we implemented a toolkit for the Unity engine that you can use to put different redirected walking techniques into a level. For example, here we have a level. This was the spacewalk demo that we did, and the actual tracking space is only 4 by 4 meters, but the virtual world is much larger. It's approximately 45 square meters, so 3 times as big as the tracking space. And here you can see the different redirected walking techniques that you can just like integrate into this level. So we have here impossible spaces, which are overlapping rooms. We have rotation gains that turn the player around in place while he's doing something, or curvature or bending gains that guide you on a different path in the real world than you experience in the virtual world while walking. And we can also see all of these in action right now in this video. So there we have the floor projections, and when the user walked around this corner, you saw that they switched something. These are the overlapping rooms, these impossible spaces. And now when the user is, this is task putting the lasers from one point to another, the whole environment is turned around him. So you can see it on the floor projection that it rotates around the user every time a little bit when he moves his head. So just his head rotation is amplified in the virtual environment. And in the end, another part of the level is inside the walkable area, and he can just continue walking down this corridor now. And the third technique that is there is when he's walking down this corridor, it's also rotated a little bit. So he can enter this room in the ending. And this is done for single players, and with Frozen Factory we now had the challenge to make this work for 2 players, and 2 players that share the same space, which was a challenge. You can see it here again. We used also these rotation gates that turned around the environment around you. We have both players in the same space, but we divided it at this point. So each has his own space, and at one point they also have a task to do and are rotated around. And afterward they walk back the same path in the real world, but on a different path in the virtual environment. Here you can see the task that they need to do, like catch ice cream drops, and then they walk away in different virtual directions. So in the real world they are still side by side, but in the virtual environment they are at completely different locations. And this was also pretty funny when users are in this game. They don't expect this, they don't know it, and if they remove the headset then and see that the other player is directly next to them, they said, wow, I didn't notice that he's next to me. I thought he would be very far away. So we had in the real world we had the walkable, or the play space was 3 by 5 meters. I already said this, and the walkable area that we had in the game was much larger. And here's again the example of this rotation game where the users walk back and forth basically. This is the whole level. It has a virtual environment of 75 square meters, so much larger than the real world tracking space. And we had different areas here. So in the beginning, it's now this red area. The players started there, and they were sharing the space. So both of players could explore the whole area of 3 by 5 meters. Then we divided this area, so each player had his own space. We rotated them with the rotation gains, and then they there was a part where they had their own paths. So one player walked on this right side and the other player walked on the left side. And in the end of the game, here in this area, we we merged this again, and they had again a huge space where they could explore the whole space freely. So there again, there was a one-on-one mapping, and real and virtual positions of the players matched again. We had some issues with co-located play, so it was not only the challenge to arrange the level that this worked, what I just showed, but it was also that the first time we tested this actually in the same space, we noticed that players were bumping into each other because they did not have enough space. So this video is actually from another game from our current project that we're working on. This is why you see 3 players here. But for Frozen Factory, we had the same issue because we didn't think of the interaction and the interaction space that each player needs. We developed this during the first lockdown last year, and all of us were sitting in home office, and we tested just online together. And so each player had enough space around, but the first time we then tested it together in one space, we noticed like most of the interactions that we implemented need a lot of space. You just need to be able to like move your arms around you. We noticed that people were bumping into each other or hitting each other with their arms and hands and so on. And so we needed to basically redo the level design and let more space for each player to be able to have a personal interaction space, basically. And another more funnier coincidence of this co-located play was that it actually was not only fun to be in the game itself, but it looked also very fun for bystanders. Like when you just watch people playing this without seeing what they see, it still is it's just really funny to watch them. And if we showed this to people, they really were surprised and wondered what these guys are doing there. And of course, you can also not see what they are doing, but it's still, you can also just watch even if you don't know what happens in the virtual environment. Okay, that was my talk about the development of our game Frozen Factory. If you have any questions, I'm now available to answer them. Thank you very much.